In this video, we'll talk about rational and irrational numbers, how they're defined, and this will just kind of be an intro video to both. So let's begin by talking about numbers, in particular number sets. So the first set of numbers that we're aware of is called the natural numbers. And this would be the set including 1, 2, 3, 4, so on and so forth. So the idea of being able to count rocks is usually my go-to example here. Okay, and now if we take a step up, we may notice there's some numbers that are missing here. The next set is called the whole numbers. And that would be 0, 1, 2, 3, 4, so on and so forth. And you might ask yourself, well, that's not too different from the naturals. Why don't we just lump them into the same set? And the reason for that is that it took a long time to generate a concept of zero, of having nothing. So we distinguish it as two different number sets just purely based on the fact that it took thousands upon thousands of years to distinguish that idea of zero. Okay, the next set is called the integers. And this has our negatives. So we have -3, -2, -1, 0, 1, 2, 3, so on and so forth. And the idea being it's all the whole numbers and their negatives. So the set has essentially doubled in size. Okay, and then you might still be noticing, hey, we're missing some numbers still. What about the halves? What about the fifths? And that's where rational numbers kick in. So a rational number, and there's two working definitions, and we'll talk about those in a second, but yeah, we are adding in those missing numbers. And then it also turns out that with rational, we're missing some more numbers, and that's where we have irrational numbers. And we're going to talk about what these two mean. So let's talk about what it is to be a rational number. A rational number has two working definitions. The first being a decimal that terminates, meaning it ends, or repeats. Okay. And then the second definition is I can write it as a fraction involving only integers. So like, for example, let's take a half. Well, it meets that. It's 1 and 2 are the integers, therefore it's rational. Also, 0.5. It's a terminating decimal right here. 0.5, full stop. So it meets both definitions, so therefore it's rational. If I look at, say, 1/3, well, as a decimal, this is 0.33 repeating. It keeps going. It's just 3, 3, 3, 3, 3, 3, 3 forever. It meets the first definition, no problem. It's a fraction. 1 and 3 are my integers, and it also meets this repeating requirement. So both of these are examples of rational numbers. Now you might find yourself thinking, okay, what about a number that doesn't terminate and doesn't repeat? Well, that would be an irrational number. So it doesn't repeat and does not terminate. Meaning there's no pattern to it, it never kind of comes around anything. I can't write it as a fraction involving only integers, and kind of the classic example of an irrational number is pi. Now pi is 3.14159, and it keeps going. There's no pattern, it never starts to repeat, it just keeps going. And there are some other numbers. There's Euler's constant, normally we write it with an E. There's also square roots of weird squares, so like 2. The square root of 5, both of those would be examples of irrational numbers. And we'll talk about these square roots in a later video, but just to kind of help it make sense, an irrational number is basically it's not rational. It doesn't repeat and it doesn't terminate. And these are just some classic examples.